Welcome to hardatengineer.com. I am Varun Patel. In this video, you will learn about how to read P&ID. Piping and Instrumentation Diagram is also known as Process Engineering Flow Scheme, which is PEFS. You will learn how to read P&ID and PEFS with the help of actual plant drawing. P&ID is more complex than of PFD and includes lots of details. Because of this, you have to watch the video till the end to understand all the aspects of this drawing. Please subscribe to my channel because it helps me to increase my reach on YouTube and you will get regular updates on new video. You can subscribe right now by just clicking the subscribe button on the right hand side of the screen. What is P&ID? P&ID is a graphical representation of the actual process plant using various symbols that represent actual equipment. As said earlier, it is a complex than PFD. A single PFD can have a multiple P&ID. This means if some system is shown on a single PFD, to show the same system on P&ID, it may require multiple P&ID sheets. It is one of the main deliverables of the FEED, that is front-end engineering and design. It is used during entire life cycle of the plant. That means during pre-EPC, EPC and operation. Use of P&ID during pre-EPC. P&ID is used to derive project capital cost estimate. It is also used to develop EPC contract specification. Plot plan is developed considering the various input from P&ID and physical site locations. Use of P&ID during EPC phase. During EPC phase, P&ID is used to develop the individual unit layout. It used to identify hazardous area classification, preparing datasheet of the equipment, walls and instrument. P&ID are used to develop the piping layout and preparing bulk material takeoff for the piping, electrical, instrumentation and civil. It is a key document for various reviews such as HAZOP, SEAL and operability review. During operation, you have to maintain P&ID in such a condition that it will show actual plant condition at any time. It should be updated when any physical change is made so that the unit will remain compliant with code, standard and specification and can be operated safely under the defined process condition. P&IDs are used to train operator and engineer before they start work in the actual plant. What information does P&ID provide? All the equipment including installed spare and associate piping including drain and vent line. Insulation or jacketing requirements, instrumentation, heat tracing and insulation detail, information about utilities, piping components including their size, class and tag number, information required for design, construction and operation such as slope of the line, minimum and maximum distance from the equipment or instrument, minimum straight length after instrument. What is not included in P&ID? Process condition and physical data, operating conditions, stream flow details, equipment locations, pipe routing, length and fittings. Support and structural details are also not included in P&ID. Okay, now you know what P&ID is and type of information you are going to get from the drawing. Let's confirm this with the help of actual P&ID. Before you move further, please like and share this video because it helps in YouTube ranking. This is the PFD of the flushing oil system. Shows the entire system of pump seal flushing oil. This is the simplest system with just one corn roof tank and two centrifugal pumps. The pump used in the heavier product such as crude, fuel oil, required flushing oil to keep the pump seal clean. Here, ultra low sulfur diesel is used as a flushing oil. You can see here that ULSD is coming from diesel rundown line to the tank, and with the help of pump it is supplied to the various pump of ISBL and OSBL units. Hope the function of the system is clear to you. Now let's move to P&ID. There are two P&ID for OSBL part of this system and many more for ISBL part. I will explain you OSBL part of the system. Reading P&ID is nothing but the reading of symbols. So if you have not seen the earlier videos on P&ID symbols and how to read PFD, it will be difficult for you to understand this drawing. Links of these videos are given in the description. So please watch these videos if you have not seen for proper understanding of P&ID drawings. If possible, get a print of this P&ID in A3 and follow the video. You can download this P&ID by visiting my website hardhatengineer.com. The link is given in the description. It is always a good practice to start reading P&ID from the main incoming line and follow the fluid path. Here ULSD is coming from DHT. You can see that. Remember the black hat on the arrow? You have learned this in the how to read PFD video. It means diesel is coming from different unit. Here you can see the line number. It is 150 mm diameter line as per DN standard, which is equivalent to 6 inch NPS. The different company follows different terminology for the line number, but it contains same information such as line size, unit number, commodity code that identify fluid inside the line, circuit number, line sequence number, piping class that gives all the detail about piping components and their material, insulation and coating requirement. Here N means there is no insulation. If there is H, then hot insulation, C is for cold insulation, A for acoustic reduction, P for personal protection, F for fireproofing. It also gives information about whether the line is steam trace or electrical trace. Normally, ET is used for electric tracing and ST is used for stream tracing. Let's move ahead. Here you can see that diesel line is divided into two streams. We follow this stream. 6 inch line is getting reduced to 4 inch. Don't get confused with the reducer symbol. It is just indication of the line size change. In piping, it can be a reducing T as it is 6 to 4 inch concentric reduction. Now, this triangle with the line indicates a line break. A line break is the demarcation of the line number change. So, whenever this symbol is used, it indicates that from that point onward, line number is different. This is the bypass loop for the flow transmitter. You can see that Venturi type flow meter is provided in between the two gate valves. Why did I say it is Venturi type flow meter? Letters VM indicates the type of flow meter. It gives flow indication on the control panel. You can see the connection shown between FT and FI. From the piping point of view, you can see that there is a 25 mm drain valve is given in between the two gate valve. The letter D indicates that it is a drain valve, and if it is a V, then vent valve. Of course, if it is vent, it is shown on the top side, not on the bottom. The bypass valve is also a gate valve which will remain closed during normal operation. You can see the letter NC which indicates the same. Reading P&ID is nothing but reading P&ID symbols. So if you are aware of the symbol, you can easily understand the P&ID. Here you can see the motor operated butterfly valve. Lots of instruments are shown here, but it is not that complicated. If you are aware of MOV, you know that it can be operated locally or from control panel. You can read at valve label, that means this instrument function is available on the valve itself. HS indicate hand switch. With these switches, you can put MOV on manual control or remote control. That means on panel control. You can also start or stop the valve from the field. HSO means open, HSC means close. The data link indicates this valve is connected to the control panel. The last two instrument bubbles shows the position of the valve. From field, you can set and see the percentage of the valve opening. Next is drain valve that is located at the lowest point. This is the spectacle blind with normally closed configuration. If the dark ring is toward the valve, as in this case, it indicates that solid ring covers and isolate the joint during normal operation. If the only circle is toward the valve, as shown here, that means the hollow ring is there and the line is live during the normal operation. Below the drain valve, the funnel is shown. So when you drain ULSD, it will go to COC system. COC means continuous oil contaminated that used to drain hydrocarbon. The second type of drain is AOC, that means accidentally oil contaminated system. After dike valve, there is a pneumatically controlled globe valve is there. You can see the pneumatic line symbol. Like MOV, the pneumatic valve also has various switches to operate the valve locally and from the control panel. You can also see the three-way valve connected to the pneumatic line to operate the actuator. You can refer the abbreviation table to understand the meaning of all these instrument bubbles. I have attached this table with the free download. The link is given in the description. You can see that there is a relief valve in bypass. It is used to protect the actuator from the surge. Next is tank. First, I will explain you mechanical parts and then instrumentation. As you can see, this is the fixed roof tank. On the top of the P&ID, you can see the detail of each of the equipment shown in the drawing. Let's see the detail of the tank. The tank is 7.5 meter in height and 8.25 meter in diameter. You can also see the operating pressure and temperature of the tank. The material of the construction is carbon steel and there is no insulation. Now let's go back to the tank. N1 to N17 are nozzle number. P&ID don't show the exact location of the nozzle, but it shows the size of the nozzle. Manhole are shown as M1 to M3. The broken line shows internal piping. There is a vortex breaker with N8 nozzle connected to the pump suction line with normally closed gate valve. This is because the main suction line is N2. N8 will be used only when you want to drain the tank completely. There are two more nozzles N9 and N10 that used to drain the tank to COC. This is open type liquid seal that prevent air ingress into the tank. Now let's check the instrumentation. For safe operation of any equipment, you have to monitor pressure, temperature and level. Here you can see the pressure transmitter near the tank bottom plate. On the top of the roof, you can see the radar type level indicator and transmitter. The temperature gauge is shown as TE, that is temperature element. This arrangement shows the multiple thermocouples installed at the different height of the tank. This will ensure that you will get an average temperature of the tank, as the liquid has a different temperature at the different level. LZT is a level safety transmitter. Here you can see the value of LLL, HLL and HHLL. LLL means low liquid level, HLL means high liquid level and HHLL means high liquid level. LLL protects your pump. When tank level reach to LLL, it gives the alarm in control panel, and based on the logic configuration, it may trigger to switch off command to the pump. HLL and HHLL will use to protect the tank from overfilling. When liquid level reach to HLL, it gives an alarm, and when it reaches to HHLL, it will trigger the safety logic and stop the fluid supply to the tank. There is a breather valve on the tank. It will protect the tank from overpressure and vacuum. Now, these all instrument bubbles are sending the information to the local and main control panel for the pressure, level and temperature instrument that I have explained to you. You may have noticed that there is a tank gauging system which received the all input signal from the instruments. Tank gauging system is used to calculate the quantity of the liquid stored in the tank at any given time. Based on the diameter, level and temperature, it will calculate the quantity of the liquid stored in the tank. QI is quantity indicator. In the last part of this video, let's check what is going out of the tank. ULSD from the tank is supplied to the pump with the help of 150 mm pipeline. You can see that inside dike there is a manual gate valve with the bypass arrangement. There is a safety relief valve on the bypass. Outside the dike, you can see the motor operated butterfly valve. This MOV has a similar switches as I explained earlier to operate the valve locally and from control panel. If you know the instrument legends and symbol, you can read and understand any P&ID. You can download this P&ID with the instrument code table by visiting my website hardengineer.com. Don't forget to subscribe to my channel to get regular updates on new video. Please like and share my video with your friends. If you want to request a video, write in the comment. See you soon. Goodbye. Take care.